Hi guys, how are you doing? So today's video is an improvement of the other. You can now see me clearer and you can actually see the real Ian. No filters, no background removers and whatnot, but in some custom lights that try make the video so cool. That's it and done. Today's concept is gonna be building on top of what we did in the previous recording, now where we did an overview of what Spring AI does. We talked about the various things such as it having a structured output. We talked about the chat client API, which is like enabling us to interact with all these models, among other things that we did talk about. So if you've not watched the video, please do watch what we did previously. So today's topic is gonna be AI concept. So in a nutshell, let me just remove this guy here. That's fantastic. So this video today is gonna talk about the AI concepts, and really what this is trying to do is catering for those developers that have not been AI engineers or have not interacted with building AI models and whatnot. Just like help them understand the basic concepts or the foundational things that a developer needs to have for them to implement or interact with Spring AI and use it to build AI applications. So this section is going to describe the core concepts of Spring AI, and like we said, no slides, nothing fancy. We're just using the docs to help us understand even better. And if things become complex, we definitely are going to ask GPT or Google it so that we understand it better. Okay, so yeah, this is very important for you to understand how the ideas behind Spring AI are or is implemented. So the first thing that you as a developer needs to understand is what a model is. So there's a lot of details here that you could read on your own, but the main thing I want you to get from here is a model is an algorithm that is designed to process and generate information. They often mimic the human cognitive functions. So they do this after or by learning patterns, insights from large data sets. So you need to always provide like a data set from where your model will be making the decisions from. So these models can make predictions, they can produce text, they can produce images or any other outputs, videos. So they are models that support video generation, transcription, and then enhancing various applications across all the industries that are available. So that's a model. So ideally an algorithm that is designed to process and generate information. And then how do they process the information? So information is processed data. So it needs to have a way of learning or getting the insights from data sets that are provided there for you. The other bit is so the other important thing is this one here. So the categorization of models. So we have based on their input and output type. So we have this one. We have the input data types and then the output data types and then the generative AI or Gen AI model specialization. So here we have the type of input that the model gets in, and then the type of output that it produces at the end of the day. So we have this one. It could take language or code, and then multimodal. Multimodal ideally means it could work around various dimensions like images, audio, and video. So this is an LLM, large language model, and then the output, the language and code is multimodal. It could produce audio and whatnot. So ideally, here we're just looking at the type of input that you give the model, the type of model that is receiving that input, and then the type of output that your model produces. So Spring AI currently has support for models that process input and output as language, image, and audio. Those are the currently supported. So there's no video support for Spring AI. So as you can see, there's one that is quite important. So these ones, I guess, if you've interacted with ChatGPT, other things like Midjourney and whatnot, you have an understanding of how they work. So but the other bit that is quite important is you could give text, image, audio, or video, and then it generates an embedding model. So we'll talk about this when you're talking about RAG architecture. So this is where you have embeddings, and then the outputs just like come in form of vectors, so numerical representation of your data. So that's vector. So yep, that's it about that for the intro bit. And then what sets models like GPT apart is the pre-trained nature. So GPT, generative pre-trained, generative pre-trained transformer. So this pre-training feature transforms AI into a general developer tool that does not require an extensive machine learning or model training background. So it's already pre-trained, so you don't have to go and train it or pre-train it again. So that's already provided there for you. So that's a model. The other thing is a prompt. You need to understand what a prompt is. So a prompt is ideally the foundation for the language-based inputs. So here we're just like ideally talking about the kind of text or input that you give it. So you go to ChatGPT. So this is the very basic example I could give. You go to ChatGPT, put in your comment there, or whatever it is you want it to do, generate an image. You ask it 1 + 1. That is a prompt that you're passing in. But there are two types of prompts. If you read here, so let me see. So so ChatGPT API has multiple text inputs with a prompt, with each text input being assigned a role. So there are two types of roles. So for example, there's a system role. So the system role is where we get the system from. So it's telling how the GPT would be behaving. So you tell your GPT, okay, this is how you're supposed to be behaving whenever a user asks you something. So that's a system prompt. It tells the model how to behave, and it also sets the context for the interaction. So if the user asks violent information, you're not supposed to provide that for them. And then at the same time, we also have the user role, so which is typically the input that the user brings. So you put in your prompt, that is a user prompt, and then there's a system prompt, the one that belongs to that tells or guides the model on how to behave and how to provide the responses and whatnot. So there was this research paper that is here. So this research paper is talking about let me just show you how it looks like. It's talking about this one. Where is it? The COT. So the notable this one chain of thought. So we have the zero chain of thought that ideally sort of like summarizes on how to best get an output from a model by telling it to think step by step, even though it doesn't have the data that it was fed. Okay, you can look at GPT, say for example GPT-3 or 4, using the 2021 data. So if you are in 2026 and you're using that kind of model and you tell it to do a thing that is not trained on, definitely it's gonna be a hassle for it because it doesn't know how to operate. So you can try make the model think step by step based on whatever it has. So this research paper found out that one of the most effective prompts you can use starts with the phrase, take a deep breath and work on this step by step. So yeah, you can just like definitely look into this, and then that should give you an indication of why the language is important, the kind of language. So this whole thing here that we're talking about gave birth to what we call prompt engineering. So it's its own discipline, and then burgeoning collection of techniques that improve the effectiveness of prompt. So the better your prompt, so the kind of code you produce, if you're a developer who uses AI to generate code, the kind of code that you produce is equivalent to the kind of prompt that you pass in. So if you pass in a very shallow prompt, you get like very shallow results or not very good results. So yeah, depends on how you also like set up your models and whatnot. And then we have prompt templates. So this one is just like for you to create effective prompts, there's a process that is involved there. So establishing the context of the request and also substituting parts of the request with values specific to the user input. So you're telling the model that the user would provide name, and then you're supposed to provide this, something of the sort. And then you have what we call the string template. Spring AI employs the open source library string template for this purpose. So for instance, consider the following simple prompt template. So you tell me this adjective, a joke about this. So what will happen is there's gonna be sort of like a mapping that happens. So this adjective would be mapped to a variable that is passed, and then the content is also fetched from there's sort of like a mapped data structure here. They're talking about it here. So a model object, typically java.util.map, is provided to populate placeholders within the template. So yeah, that's ideally about it, and that's what you get to learn from this whole process. So prompt templates are very important, and we'll get to see them when we start writing the actual code. So embeddings, on the other hand, these are numerical representation of text, images, videos that capture the relationships between the inputs that you provide. So you'd find this in whenever you're dealing with RAG related stuff, retrieval augmented generation, where you pass in your, could be a book, so this is in the form of a text, could be a markdown, could be images, could be videos, and then there's a numerical representation in form of vectors that is provided for these ones. And then the vectors, they help us calculate the relationship between the various types of inputs that we have. Okay, so embeddings work by converting text, image, video into arrays of floating point numbers called vectors. So what is a vector? A vector is an array of floating point numbers that represent a specific set of data. So you could have a statement like this. It could be, you could get embeddings or vector embeddings from it. So very possible. So these vectors are designed to capture the meaning of the text, images, and videos. So the length of that embedding array is known as the vector's dimensionability. Very important for you to get that. Now this is how it looks like. For you to get the embeddings, you need an embedding model. So for example, Ollama has a nomic embedded nomic embedded text that helps you come up with the embeddings. The others, I'll just like try Google them. Embedding models, yeah. Okay, so embedding models are algorithms that convert unstructured data, text, images, audio into numerical vectors. That's okay. Yeah, so we have OpenAI. OpenAI has text embedding 3 small. We have the text embedding 3 large. Open source like Hugging Face has BGE, E5. Google has Gemini embedding 001, 002 preview, and yeah. So yep. That's just like a way of converting. So there's specific models that help us convert them. So algorithm that convert unstructured data into vectors or numerical representation. So if you have a word like Ian, for example, so it would have an embedding like this one. So for this case, we are dealing with countries, I guess, like Swaziland, Maldives, and whatnot. So yeah, all of them, their embeddings are generated like that, and then once the embeddings are generated, they are stored into what we call a vector store. So a vector store is in charge of storing the vector embeddings, but we'll see it when we get to actual code. So as a Java developer exploring AI, it's not necessary for you to comprehend the intricate mathematical theories or specific implementations behind this vector representation. So very important, like I said, you don't have to master all of these things. What you need is just like the fundamental of understanding. So a vector is just an mathematical representation of a given input. So a basic understanding of their role and function with AI system surfaces, particularly when you're integrating AI functionalities into your application. So you need to understand what embeddings are, how they are generated and whatnot, and then for you to use them at some point. So embeddings are particularly relevant in practical applications like RAG. Like I said, RAG, this is where you'd mostly use the RAG, the embeddings, yeah. So the other bit that was quite important is they enable the representation of data as points in a semantic space, which is akin to the 2D space in the Euclidean geometry, but in higher dimensions. So what this actually means is just like how points on a plane in the Euclidean geometry can be close or far based on the coordinates, in a semantic space. So when we speak semantically, we mean that the proximity of points reflects the similarity in meaning. So the proximity of the points in how you represent them. So we have vectors, an array of a numerical representation of your input. So if you have like a bunch of inputs and then these inputs have the proximity of the points, you remember, it's just like floating points. If they are close to each other, it means that they have a similarity in the meaning. So sentences about similar topics are positioned closer in the multidimensional space, much like points lying close to each other on a graph. So this proximity aids in tasks like text clarification, semantic search, and even product recommendations, as it allows AI to discern and group related concepts, location, and in the semantic landscape. So if we look at this one, so how Netflix recommends a movie. So let's just say how Netflix recommends a movie. A movie based on what I am watching. Yep, that's it. Okay, yeah. For theirs is a bit complex, I guess. Real-time personalization, deep learning, understand the complex. Okay. We take feedback, for example, the titles and whatnot. Okay, let's just ask it directly. Practical applications of embedding. Yeah, semantic search, recommendation systems. So embeddings help platforms like e-commerce, streaming services, and social media identify representation. User who liked this also liked, something like that. Clustering. So I guess like if you look deep into it, because of time, if you look deep into it, you'll get to see how the embeddings like find the application in real world stuff. But yeah, I tend to believe that whenever you're trying to recommend something, they definitely are fetching like from the embedding and whatnot. The other bit is tokens. So tokens, these are the building blocks of how an AI model works. So you have a specific input, the model converts the word into token. So on the output, they convert the token back to words. So you get on input, they convert your text into or whatever into tokens, and then on output, they convert the tokens they work with back to words. So in English, one token roughly corresponds to 75% of a word corresponds. So we need to have a standard way of measuring things. So there are scenarios where it wouldn't apply 75%, but mostly it's 75% of a word. For reference, Shakespeare's complete works totaling to around 900 words would translate to approximately 1.2 million tokens. So one word, 3/4 of it equals to a token, so you can do the math and then get to see how we get that to this one. Yeah, very very important concept that you also need to get here is the tokens you use equals to the money you use. So it's a measure of if you go to Azure Foundry, you will see that they charge say $0.005 per token, or per a million, or per 500,000 tokens and whatnot. The other concept that you need is what we call a context window. So models are subject to token limits, so which restricts the amount of text processed in a single API call. So a single API call could have like a restriction on the amount of tokens that it could submit. So this threshold is often referred to as a context window. So the model does not process any text that exceeds the limit. So there are times where you could paste a very very long paragraph on GPT and then it tells you, oh, you cannot process. So it's beyond the context window. So for instance, GPT-3 has a token limit of 4K token, like that. Anthropic's Cloud has 100K token limit. Meta's has 1 million, which is very very cool. Yeah, so that's ideally it. The other bit is structured output. So here we talked about, like previously, the structured output in Spring AI. So the kind of content that an AI model would generate at the end is normally a string. So you tell it do this and then it just returns a string. So yes, even if you ask it to reply in JSON, yes, it will reply in JSON, but that is not actual JSON. So it's not a JSON data structure. It looks like JSON, but it's not like an actual JSON data structure, if you know what I mean. So yeah, it's just a string. So you also need to ask for a JSON, which is not 100% accurate. So the intricacy led to the emergence of a specialized field invocation, involving the creation of prompts to yield in the intended output, yada yada yada, like that. So in summary, instead of a person providing raw input and then they get the string as the output, as much as you might try format it into a JSON, which is not possible, there's a structure, or there's an API that is provided for us to convert the raw text that is provided into the structured output. It could be a JSON, or it could be a POJO, plain old Java object. Yeah. So we'll definitely look at that later, but yeah, just in a nutshell, this is where you could find. So the ability of LLMs to provide structured outputs, so you could pass it into any type. So there is a bunch of structured output converters that helps you convert your output into a specific format. Now, how do we bring data? How do we bring your data and APIs to the AI model? So you can try a few things, yeah. So how can you equip the AI model with information which it has not been trained on? So like the example I gave, GPT 3.5 or 4 dataset extends only until September 2021. So what if you want it to have access to recent data? How do you do that? So if you try ask it something that is today, of course, the previous models, if you ask them something that's about 2026, it's definitely gonna say it doesn't have access to this. So if you ask it the kind of content, the model, the data it was trained on, it said 2021, for example. I don't know for 2020, the latest GPT, the current data set it has, but you get the concept. So there are techniques you could use. So the first one is fine tuning. So what this means is machine learning technique involves tailoring the model and changing its internal weighting. So this is a lot of work, to be honest. Yeah. However, it's a challenging process for machine learning experts and extremely resource intensive for models like GPT due to their size. So unless you take a very, very small model, you have GPUs. So you have, you have to have a lot of resources for this one, which is like a lot of work. So we have the other one, which is prompt stuffing. So prompt stuffing ideally is you take your prompt, okay, you pass in with data. So you go copy the set book that you're reading, pass a prompt, and then paste the content. So that is prompt stuffing. In a nutshell, there is another way of prompt stuffing. So what this means is embedding your data within the prompt provided to the model. So given a model's token limits, techniques are required to present relevant data within the model's context window. So if I'm trying to get some info from a textbook, so me copying the whole textbook would fill the context window. So how do I ensure that I do the prompt stuffing in the best possible manner? So this is where an architecture called Retrieval Augmented Generation happens. But ideally, prompt stuffing looks like this. You come with your prompt, a user query, and then you embed your prompt there, and then you stuff there, and then the model gives you. But remember, if you don't use RAG, you definitely are gonna get a context window limit thing if the context is too long. The other bit is what we call tool calling. Tool calling is a technique that allows registering tools or user-defined services that connect to large language models, to the API or external systems. Spring AI greatly simplifies code you write. Okay, so tool calling ideally is you have a weather API, so you need your model to access that weather API. So how do you do that? You expose it via a tool. So a tool is just like you write code, you're hitting the weather API, but now you're passing the result of that weather API into the model, so via a tool. So yeah, there's a bunch of annotations that you use there. You could also create your own methods, but ideally, that's how tool calling happens. So onto the spicy thing here is the retrieval augmented generation. So what this means is how do we ensure that we prompt stuff our models in the best possible manner? So the approach involves a batch processing style programming model where the job reads unstructured data, from your documents, transforms it, and then writes it into a vector database. So it follows the ETL architecture. So I'll just jump straight into this this diagram here so that you get to see what I mean. So can I really minimize this one? Oh, I can. Yeah, so this is the document. So ETL means extract, E means extract, T means transform, L means load. So you have your data source here. This is your data. So we have a reader that takes in the documents, and then we have a transformer that transforms or splits the document into chunks. Then the chunks, we have a writer that writes them into a vector store. So they are written into a vector store in form of embeddings. So there's embeddings that are generated in the process of that. Now, when a person comes and asks a question, so assuming this is a book that we've written about Java, say it's a head-first Java book, so we pass it there, that is the document, it's transformed, generates chunks, and then it's fed into the vector store in forms of embeddings. So Ian comes with a chat request, hey, what are strings from head-first Java, for example, yeah? What are strings? What is the definition of a string? So what it's gonna do is gonna take the prompt, this is my prompt, and then from the vector store, now it would start now the process of retrieving, okay? So it retrieves information related to definition of a string. It retrieves that. So it's gonna query it, it's gonna come in chunks, of course, and then now this is the user query here. This is the user query, and now it augments. Augments is just like combining them. You're putting together two pieces. So it's gonna take that only the relevant bit from the book that is related to string, embed them there, pass them together. So the user query is gonna be here, and then the context is provided. So given the context and provided history, now it's gonna take from head first Java the definition of a string, put it there, and then the chat model analyzes, and then it comes back with a response for you. So that's the whole idea of RAG. Ingest data is stored in a vector database. Ask your query, retrieves related info from the DB, of course, from the vector store, augments, and then generates the response. So retrieve, augment, okay, retrieve, augment, and then generate. That's the whole thing. So we've talked about tool calling. So yeah, tool calling ideally is a mechanism that addresses these shortcomings, like state knowledge because of when was this data gotten, like when was it. So there's other tool annotation that's used, we'll get to see it, but ideally you have a tool. Spring AI is here, it has like the dispatch tool request. A person comes to the chat request, they provide a name. Okay, there's a tool definition, there's the name, description, and the input schema. So this tool is called get current weather. So it's a method just like any other. It has a name, it has a description, and then it has the input schema. So what kind of data do we expect? And then a person comes with their request. The dispatcher tool called requests finds, based on the description that has been given, which tool can do this, gets that tool, performs, and then you get a response from it. So that's the whole, this is the whole thing here, this cycle. So when you want to make a tool available to the model, we include its definition in the chat request. Each tool definition comprises a name, description, and the schema of input parameters. So when the model decides, to call a tool, it sends a response with the tool name and the input parameters model. The application is responsible for using the tool name to identify the parameters, and then the result of the tool is processed by the application, and then the application sends the tool call result back to the model, and then the model generates the final response. Yeah, so we'll talk about function calling as well, but that's ideally it. So we talked about evaluating the responses. So here is, we're just like looking to ensure that the output of our AI system in response to the user requests is very important to ensure that the accuracy and usefulness of the final application. So yeah, we are trying to ensure that the model is not hallucinating, and we have an evaluator API which currently gives access to the basic strategies to evaluate model responses, and yeah, we'll talk about that later. So thank you very much for tuning up to this point. That's 30 minutes walkthrough into this. Yeah, that took me long. But I hope you've gained something. You now have a fundamental of understanding of these concepts, so that when we start generating, writing the actual code, you get what we're doing. So thanks for watching up to this very end. You can support me by hitting the subscribe button, suggest what I can improve on or what we can deliver better and the topics to cover. So the next possibly is getting started now, where we start doing the real things. So we go to initializer and do a bunch of things. So thank you for watching up to this point. Hit the subscribe button, notification, and like. Have a good one. Adios.